What we're asked here is find the area enclosed by the curve y equals x squared and the y-axis from 1 to 4. Now, most of you might not know what the line y equals x squared looks like, so what you might need to do is you might need to go to your table function. You might want to put in x squared, and you might want to remind yourself what does it actually look like. So let's go from -6 to 6. Step 1. Simon, describe this graph for me, looking at these numbers only. What way does this graph work? No, by the points?
U-shape.
And it stops at 0, 0 and goes back up again. So, just by using your table function, you can automatically figure out the shape of this graph. You know that it crosses down here and it goes U-shaped. Now, once you figured out that U-shaped graph, it wants it pinned up against the y-axis, and in between the lines y equals 1 and y equals 4. So, what can we say about this area here? Symmetrical on both sides. So if I get the blue area, I can multiply it by 2 to get the full area. Do you understand? So we're going to get the integral of x dy from b to a. Now b is going to be 4 and a is going to be 1, so it's going to be 4, 1. Now what is x on its own? X squared equals y, therefore x is equal to y to the power of half. Y to the half dy. Now, upon completion of this, what we're going to do is we're going to integrate. Remember the whole n plus 1 business. We're going to be y to the power of 3 over 2. I have a fraction, need to turn that upside down in front. 4 to 1. Somebody quick on the calculator would be brilliant. 2 over 3, 4 to the power of 3 over 2. Minus 2 over 3, 1 to the power of 3 over 2. Now, upon completion of this, I reckon the second one's going to be minus 2 over 3. I don't know what the first one is. I think the first one might be 16 over 3. And I think the full answer is 14 over 3. Was it? Change it into fractions for me, please.
Yes.
Answer there is 14 over 3. Okay. Next part. The diagram shows the part of the curve x cubed minus 12x squared plus 36x and it touches the x-axis at 0, 6. Okay? Now, just for argument's sake, let's say in the test I wasn't that nice and I didn't give you that information. What could you do? Factorize out x squared minus 12x plus 36, and then you get x times x minus 6 times x minus 6 equals 0, and then your answer would be x equals 0 or x minus 6 equals 0, x equals 6. They don't have to give you that information, so you should basically know how to get it anyway. Okay, so now that that's not even part of this official question, this is just what happens if they don't give you the 6, 0. Okay, so we have 0 and 6. Okay, now
Would this be difficult to the exam?
Sorry?
Is this the same difficulty as something that would come up this summer?
Yeah, actually, yeah. I think you should be quite happy with the integration question. If you've successfully done the homework recently, I say you'd be quite happy. Now, not even that. It's quite straightforward, actually. The y dx, guys, coordinates of the maximum point. What happens at the maximum point? What happens to the slope? Slope is 0 at the maximum point. Okay? And it's also 0 at the minimum point. Remember, differentiating is the slope. You're going to get 3x squared minus 24x plus 36. We're not integrating, we're differentiating this time. I'm going to put that equal to 0. I'm then going to divide by 3. Because dividing by 3 will help me solve this. And then I'm going to get x minus 2, x minus 6 equals 0. And then I'm going to get x equals 2 and x equals 6. We already know that x equals 6 is the minimum and we know x equals 2 is the maximum. For argument's sake, how would you convert it?
Integrate twice.
Differentiate the second time. And you don't differentiate this part, you got to differentiate the original. 6x minus 24. And if x equals 2, you're going to get 12 minus 24, which is less than 0. And when it's less than 0, it's a max. Okay? That's differentiation revision right there. Now, once you've sorted that out, it asks for the coordinates. It doesn't want you wasting its time. It wants the coordinates. So, the coordinates is x equals 2. So what I'm going to do is I'm going to go up to x equals 2. And I'm going to replace x with 2 for this y value here. Y equals 2 to the power 3 minus 12 times 2 squared plus 36 times 2. I'm going to get 8 minus 48 plus 72. And I think the answer is 232. And we got that confirmed? 232? Okay, 232 it is. Now,
is that 2 coming from the
differentiation to get a max value? Yeah. Now, I could have also done the table function, lads. And the table function, I could have just put down x cubed here. So x cubed. And then I'm going to put down minus 12x squared.
This is like a totally valid way to get your answer in an exam.
Which one? One down here?
Yeah.
You would show the workings, so you would put down replace in 2, but you can still have your you can still check it. Huh?
You still find your max point in it.
Yeah, but sorry, to get full marks or a max point you'd have to differentiate. Okay. So 0 to 6, guys. Up in ones. Look at this. So 0, 25, 232, done. Now, Simon, make a prediction for me. If 232 is the maximum point, what will 3 be? 3 what? 325. It has to be symmetrical around the maximum point. 327? That's interesting. Oh, it has to be symmetrical for a quadratic, not a cubic. Okay, so that saved me there. Okay, so use the trapezoidal rule to estimate the area of the shaded region. So guys, if anybody remembers the trapezoidal rule, okay, here's the trapezoidal rule here. Let me show you. Trapezoidal rule is area equals is a width over 2 or h over 2. It's going to be y1 plus yn. Yes, it is. Plus y2 plus all the way up to yn minus 1. Now, let me show you what this means. It's definitely over 2, is it? That's the only thing I'm not sure about. Is it the trapezoidal rule divided by 2?
H over 3.
Sorry?
H over 3.
Does that say Simpson's rule beside it or trapezoidal rule?
Oh, man, that's the answer.
It is 2. Okay, thank you. Now, guys, look at this. What I'm going to draw is I'm going to divide this up into 6 equal slots. 1, 2, 3, 4. Now it's not exactly great, but I'm going to show you my numbers. Okay. Now it's going to be 0. Just 1 second, guys. Just one here. It's going to be 0. Will somebody just help me fill in this for a minute before we do that? Just remember these numbers, will you? 25, 32, and 27. So 25, 32, 27, and after 27 it's 16, 5 and 0. So 16, 5 and 0. Okay, I believe I have a question over this side. Yep. Sorry guys, it's 2 times. Now here's the way I have remembered off by heart. First plus last, 2 times remaining. Okay? First plus last, 2 times remaining. Now, what is the width again, guys? The width is going up in ones. It's the same thing as the step in your calculator. 1 over 2, y1 is 0. Y2, or sorry, the last y is also 0. Now 2 times the remaining is going to be 25 plus 32 plus 27 plus 16 plus 5. Would somebody be good enough to just zone in on this part for me? Put that into the calculator. Okay. 2 times 2 brackets 25 plus 32 plus 27 plus 16 plus 5.
So what's the relevance of the inside bracket where it says y squared plus y minus?
That's not y squared, that's y2. Rory.
Oh, I see. Yeah.
This one's the first height is 0, last height is also 0, and 2 times all the heights in between added together.
So what does y minus 1 mean?
yn minus 1 means the second last height.
Because n is the last one.
N is the last one, n minus 1 is the second last one. Okay. Shh. Now, what do we get?
210.
105. 101.
Multiplied by 2 is 210, and then when you divide it by a half, like Shane said, it goes back to 105. Is that right? The full answer is 105. So, guys, when we integrate, we're expecting something around 105 to do this, okay? So we're now going to integrate. What's the formula again? X cubed. What's it? Minus 12x squared plus 36x dx. 6 to 0. Connor Foley, will you integrate this for me, please? So what's the integral of x cubed?
3 for x4.
x4, and what's at the front then?
3.
A quarter. Quarter x4. What about the next one here? What happens when you integrate x squared?
12x.
No, just x squared and 1 to 12 at the moment.
x3.
x3. And if you have a 3 here, you have to have a 3 below. 12 divided by 3?
4.
4. Okay. 4x3. Now finally, 36x. What does the x turn into?
Stays as x.
No, it turns into x squared when you integrate it. And guys, x squared means you have a 2 underneath, because you have to put whatever the new power is, you put it underneath. And then 36 divided by 2? 18. Okay. Now, 18x squared from 6 to 0. What's the great thing about having the 0 seconds? They're all going to be 0, so then you just have to concentrate on the 6. Now, will somebody get on the calculator on this one? A quarter 6 to the power 4 minus 4 times 6 to the power 3 plus 18 6 to the 6 squared. Okay, and we're hoping it's somewhere in the 105 region. If not, we've gone completely wrong on one of them. So let me know the minute you get the answer. 108. Okay guys, 108 meters squared. Now guys, could anybody suggest a method for getting a better estimate of the trapezoidal rill?
Putting more in.
Sorry?
Putting more y's in.
Put more y values in, and therefore putting the step at lower 0.5 will make us more accurate. If you did 0.1, it would make us ridiculously accurate. So the smaller your step, the more accurate your trapezoidal rill is. The smaller this value is, and the more y values you have, the more accurate your trapezoidal rill is. That's good, guys. Okay, 28. Now, 28 is Freddy's Fish and Chip Shop uses the logo of the curves as shown here. Okay? Now, the curves are used as y equals minus x squared plus 4x and y equals x squared plus 4x plus 6. From x equals 2 and x equals 4. Now, we're sort of lucky. They really sort of line these up for us. We know the intersection points right away, don't we? X equals 1 and x equals 3. Once again, I'm going to prepare you for when they don't give them to you. How would you find x equals 1, x equals 3 if they didn't give it to you? You'd say that the two curves equal each other. You'd get minus x squared plus 4x. You'd then get x squared minus 4x plus 6. Bring them over to one side. You're going to get 2x squared minus 4x plus... Sorry? Minus 8x, sorry. Plus 6. Divide by 2, x squared minus 4x plus 3, solve that, x minus 3, x minus 1 equals 0, you get back your x1 and x3. That's no bother. That's extra, you don't even need to do that, but in a test they're well entitled not to give you any of those points. Now, once we've done that, what I'm going to show you is this, okay? there's going to be a lot of double counting going on, and that's the problem with this. I'll show you now. I'm going to zone in on this area here. Now, the first thing I'm going to do is I'm going to get the red area. I'll describe it now. Here is a red area. How can anybody tell me how to get that red area there?
Just integrate the blue curve from 2 to 1.
Integrate the red curve. The red one's here.
You do the blue ones, huh?
I will do the blue one, just let me do the red one first. The red curve from 3 to 1. Is the red curve the U-shaped or the N-shaped? U-shaped, which means it's the plus x squared. X squared minus 4x plus 6 dx. Now what Simon was getting at is correct. What happened here is, if I integrated the blue part, I'm getting this part here. Now what's happening there? I'm double counting the white region or the red region underneath. So I'm going to subtract them away from each other. So I'm going to get 3, 1, the integral of minus x squared plus 4x dx. And I'm going to take away 3, 1, the integral of x squared minus 4x plus 6 dx. Do you understand that? Okay, so that's what I'm going to do. Now, all of this is only going to get me region 1. Haven't even gone near region 2 yet. So this is just for region 1 only. So let's look at this. So we're going to get minus a third x cubed plus 2x squared from 3 to 1. Then I'm going to get minus a third x cubed minus 2x squared plus 6x from 3 to 1. Now, what we can do here,
Instead of interesting, don't put dot marks, we're not putting in a C value.
no, I would be showing you that other was. Okay, so guys, what we're going to get here is minus a third 3 cubed. We're just going to do them separately starting off, okay, so I just want you to just purely concentrate on this one here for the time being, okay, and then we're going to take away the integral of minus a third 1 cubed plus 2 times 1 squared. Okay, now what I found in a test, if you're looking for a bit of a test technique, what I found out was I was actually much better just doing part of it myself and then at the end using my calculator. So what I was doing at home,
22.
well, Connor Fagan's very fast at it, so 22 over 3. What I was doing at home was this, guys. I was doing it like this, minus 9 plus 18 minus bracket minus a third and then plus 2. And then I was entering that part into my calculator because it takes a lot less time than entering in all the brackets and powers. Now, then what would happen now is that this is 22 over 3. Okay? So this is 22 over 3. And this 22 over 3 now has to get this taken away from it. Now guys, how do I take this away from it? What do I need to get for this one then?
Right.
It's not the full thing. Only the black box is 22 over 3.
No, I think. Wait, I don't know.
That's, we're next going to do what's in the purple box here. Okay? So Connor, once again, if you can use your skills there. Third 3 cubed minus 2 3 squared plus 6 times 3. Now we're going to take it all away from a third 1 cubed minus 2 times 1 squared plus 6 times 1. Please remember, once again, exam technique will dictate that because it's the number 1, you don't need to put in the powers because any power of 1 is still 1. So you don't need particularly to worry about that. Now, we're expecting a positive answer because it's above the x-axis. So what is it?
9.
Is it 9?
14 over 3.
Minus 14 over? Oh, sorry, it's 14 over 3, but we're then going to take it away from the other one. Excuse me. Now, what we're going to get here, guys, is 8 over 3. 8 over 3 is the answer for region 1. Now, what I do in tests as well is when I'm getting region 2, I compare their sight by just using my eyes. We should get another answer roughly around 8 over 3. It should be in the same ballpark as region 1. Okay? Now guys, can anyone in class tell me, how do I get region 2? Anyone in class have any idea how to get region 2?
Area under the red here minus area under the blue here.
Okay, what Simon said there was area of red under minus area of blue. Got it in 1. Area of the red one is here. So area of the red curve is in between 4 and 3, and it's the U-shaped graph. Okay, and then the area of the blue one is this one here, and we're going to take that away from the red one. So that's going to be from 4, 3. That's going to be it's going to be minus x squared plus 4x dx. Now look what happens here, guys. Now, happens here is we integrate, and we get a third x cubed minus, it's the same as last time, isn't it? 2x squared plus 6x, 4 and 3. And then we're also going to take away, what's it going to be, minus a third x cubed plus 2x squared from 4 to 3. And goes, look what happens here. What we're going to do is going to integrate this here. So what we're going to get is, Connor, can you try this out again? A third 4 cubed minus 2 times 4 squared plus 6 times 4, close bracket, take away a third 3 cubed minus 2 times 3 squared plus 6 times 3. Now guys, this part here only represents this part here. Okay? Has nothing to do with this side yet. Haven't even gone there. So what do we get? And we'd like somebody obviously to verify his answer. Now, lads, 13 over 3. Now, we need to do the next part now, guys. This part here, in purple, what I need you to do is this. We're going to do minus a third 4 cubed. Lads, did you get on this one right away, please? 2 times 4 squared, minus bracket, minus a third 3 cubed, plus 2 times 3 squared. Who's on this one? Connor, again, please. Yeah, you got that one there. So the full answer here was 32 over 3 for the first part, 9 for the second part. Take them away, you get 5 over 3 overall. We now get 13 over 3 minus 5 over 3. So 13 over 3 minus 5 over 3 is 8 over 3. Now finally, 13 over 3 minus 8 over 3, 5 over 3. So the first answer, this part here was, this is 5 over 3, and what was the first part? Was it 13 over 3? Add them together, and we get 18 over 3 to 6. Is the answer at the back of the book 6? The answer isn't 6, right? The calculations were perfect. It was 5 over 3. So it's 13 over 3 minus 5 over 3 gives you 8 over 3. 8 over 3 is the size of area 2. Area 2 is 8 over 3, and what I said earlier held true, that both sizes should be roughly the same. In fact, they are the same. So then when you add them together, you're going to get 16 over 3 for your entire area. Okay? So the graph of sin x is shown for 0 less than x less than 4. Verify that the area of the shaded region is 0 pi. So guys, this one here is going to be 0 to pi. Okay, it's pinned to the x-axis. So y equals sin x, so it's going to be sin x dx. Now, what happens when you integrate sin x dx? What does it turn into? Sorry? Turns into, is a minus cos. Okay, minus cos x from pi to 0. Now look at this, guys. Okay, what's going to happen here is we're going to get minus cos pi. We're going to get minus cos 0. And what that is going to be is, it's actually going to turn out to be minus 1, minus 1. And then you're going to have plus 1, get you 2. I'm going to stop there, and I'm going to let